In this video, we're going to again try to use our two cubes factoring techniques. This example, we're going to focus on the difference of two cubes. Now, this one is, I would say, a tricky problem. It's a problem, as you can see by looking at the screen. Be careful for this. And this is kind of a problem that will repeat itself throughout. It's where the common errors with factoring occur with students. So I have my difference of two cubes formula. I have this example, 2r cubed minus 250. Now I'm going to do this example, go through the thought process as if I was just a student trying this problem. And I'd see, okay, I have two terms. I'm given this difference of two cubes formula. So I'm going to try and just use this formula as is. And so what we do is, we try and find the cube roots. And so if I take a look, hey, the cube root of r cubed is r. Got it. But then I have to ask myself, what's the cube root of 2? I don't know what the cube root of 2 is. It's a weird decimal. It doesn't work out nice. 2 is not a perfect cube. What about 250? If I find, what is the cube root of 250? It's the same idea. 250 is not a perfect cube. And so I can't use the a cubed minus b cubed approach. So the question is, what do I do? How do I go further? This can be factored. So, this is the process that as students you go through. You just look at it and say, well, 2 is not a perfect cube. Neither is 250. Okay, so I guess it's not factorable. But that's where this be careful comes in. Because after doing, 5 problems, 6 problems, 7 problems, there's always one factoring technique that is forgotten by students right off the bat. And that factoring technique, and we've gone through this in the previous videos, and I've tried to emphasize it, is the first thing you always do is you always check for a GCF. And that is the process that is forgotten by many, many, many students. And that's why this type of problem is hard for some students to do, because they don't know what to do, because they look at, well, I can't use my difference of two cubes factoring approach because these aren't perfect cubes. And the answer to that is yes. You can't do the difference of two cubes in the form it's already in. But if I take out my GCF, which I see they're both even, so if I factor out a 2 from both of these, I'm going to get r cubed minus 125. And now if I take a look, r cubed is a perfect cube of r. 125 is a perfect cube of 125. And so what happens is my a is r and my b is 5. I can go directly to my formula. But if I did not take out that GCF, I would not have seen the difference of two cubes hidden inside. So that's the key here. So you always carry along your GCF. And then we're just going to use our formula. A minus b, so r minus 5, times a squared, which is r squared, plus a times b, so r times 5, which is 5r, plus b squared, so 5 squared is 25. And so I can mix in multiple techniques into our difference of two cubes. We can still use and always have to check for a GCF first. So use this video as a warning, as an eye-opener on no matter what problem you're on, you always check for a greatest common factor. Even if the previous 10 problems did not have one, that new problem, that 11th problem, you better do it. That 12th problem, you better do it. So always factor out a GCF and then try and find which factoring approach to use.